Okay, hi everyone. Let's begin. Those who are late, late lah. I'm not feeling well. Okay. So same thing, everyone. I'm at home today, so please turn on your cameras and everything. The first thing I want to talk about is we want to go into a new chapter today. Okay, so I hope you can see the screen that's in front of you. And if you have your textbooks with you, please turn to page 83. Okay, I won't be covering very much today. I just want to kind of cover the basics. Okay, we are going into this new chapter, which is chapter 3, and it's called integration. Okay, so previously, when we were learning this, we learned that if I give you an equation, okay, or an expression that connects y and x, or fx and x, for example, y equals to 5x cubed. Okay, we have previously learned that if I differentiate this, okay, I get dy dx. Okay, because I'm changing the power of x, and therefore dy dx will give me 15x squared. Okay, so this process which we are changing from y to dy dx is called differentiation. Okay, which we learned previously lah. Okay, in the chapter 2. Okay, but in this chapter, what we're going to do is we're going to be looking at it the other way around. If I give you, okay, an expression, okay, I want you to be able to go back, okay, on the differentiation. And this is what we call integration. Okay, dalam bahasa Melayu dipanggil sebagai pengamiran. Not that it really makes a difference if you know what it is in Malay. Pengamiran atau some books they call it kameran lah. Okay, buku yang lama-lama kan dia akan panggil the word kameran. Okay, but basically what it means is that if let's say I give you this okay, y equals to 15x squared. Okay, if I integrate it, okay, if I do the process of integration, I will get a new equation, okay, which will be 5x cubed. And this one, okay, how to do from x squared to become x cubed, okay, is what we call the process of integration. Okay, so this is what I need you to have in mind. Previously, when we were doing differentiation, we are reducing the power. Okay, power of 3 jadi power of 2. And then of course dia punya syarat lah 3 bawa ke depan, darab dengan nombor di depan, dan blah, 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 blah. Now, what we're doing is we are increasing the power from 2 to become 3, from 4 to become 5, from 6 to become power of 7. Okay, but of course, that comes with its own rules. Okay, dia memang ada peraturan tersendiri lah. So, you need to you need to bezakan antara differentiation and integration. Integration is you're reducing the power. Okay, integration is you're increasing the power. Of course, there are the step tersendiri lah. Okay, but the first thing that you need to know is that the process of differentiation and integration is inverse. Okay, the opposite of differentiation is integration, and the opposite of integration is differentiation. Okay, so for example, if you take a look at page 83, okay, let's take a look at example 1. Okay, if I give you d dx of 4x squared, okay, equals to 8x. Okay, what is happening here is that 4x squared, bila kita differentiate, we dapat 8x. So by that same logic, remember, integration is the opposite of differentiation. So if you integrate 8x, okay, if I integrate 8x, I will get 4x squared. There is no, for now, there is no complicated thing that I want you to remember. There's no complicated step, there's no formula, nothing. No, I don't want you to remember that. I want you to get it into your head first, that if I give you a differentiated equation, you must be able to tell me the opposite just by looking at it. Satu kali kamu nampak kan, terus kau faham sudah. Oh, okay. Jadi kalau saya integrate ini, saya akan dapat ini balik. Okay, and the sign for integration, okay, is this. Okay, this is the sign for integration. So how would I write this? So the question is find the integration of 8x dx. Okay, so this doesn't, as I said, this doesn't require any complicated calculation, nothing. It just requires you to understand. If I differentiate this, I get this. So if I integrate this, okay, if I integrate the 8x, I will get what it was before dia kena differentiate. Okay, so the integration of 8x towards dx, okay, is 4x squared. That's it. Okay, I just want you to see the relationship between this purple color one, okay, and the green color one. Okay, the green color one is selepas kamu differentiate. The purple color one is selepas kamu integrate. Atau the purple color is sebelum kamu differentiate. And the green color is sebelum kamu integrate. Okay, so this relationship is actually very easy lah. I'm trying my very best not to make it too complicated for you. Actually, it's very easy. All you have to just see is, you know, don't be scared by this ddx. ddx means you differentiate this. Okay, you get 8x. Okay, another way to think about it, if this really helps you lah, but I'm not really sure whether it does. Okay, tapi ini bukan jalan kerja, it's just a way of thinking. I'm not saying that never do this as a jalan kerja. If you do this as a jalan kerja, memang kau akan salah. Okay, another way of looking at this is like this lah. Okay, so we know that the integration of 8x dx is the one that we want. Okay, so what we can do is this dx over here, I bring it up. Okay, and I will get 8x dx. And this d, okay, this d over here, if I move it across, since d is for differentiation, if I move it across, it becomes integration. Okay, so the integration of 8x dx, and what are you left with? You are left with 4x squared. Okay, you can think of it in that way lah, if you want. So even if it is a very super complicated one, okay, say for example, okay, d dx, let's say I differentiate 4x squared plus 2 over x cubed plus 3, okay, equals to, contohnya, okay, contohnya is 4x to the power of 4 plus 3x plus 1, contohnya. Okay, so my question to you is, tell me what is the integration of 4x4 plus 3x plus 1 kepada dx. And the answer is, one time you see, you know. Okay, no complicated calculation, nothing. All you have to see is this relationship. Oh, okay, kalau saya differentiate yang besar, complicated ini, saya akan dapat begini. Tapi kalau saya integrate ini, saya akan dapat 4x squared plus 2 over x cubed plus 3. Because integration is the inverse of differentiation. Okay, when I integrate something that has already been differentiated, I will get the original equation. I repeat, when I integrate something that has already been differentiated, I will get the original thing back. Okay, it's not difficult, okay, it's just one-way street, and the other, actually it's two-way street lah. No, kau pergi sana, kau bagi balik. Okay, no complicated calculation involved, at least not now lah. Okay, but this understanding is very important, because when you fail to understand this very fundamental thing, this whole chapter becomes very difficult. Okay, so I'm going to spend a little bit of time to make sure that I'm drumming this into your head lah, sampai dia masuk dalam otak kamu. Okay, take a look at page 84. Okay, page 84, self exercise. Okay, 3.1. Okay, you're given d dx, means if I differentiate, this is the original thing, okay, equals to 15x squared plus 4. Okay, so this is my original equation. This is already differentiate. Okay, the question is, find the integration of 15x squared plus 4 kepada dx. So what happens when you integrate something that is already differentiated? You will get the original answer back, which is 5x cubed plus 4x. Nothing complicated about this whatsoever. It's just the understanding of this very, very basic, very basic, very basic relationship. Okay, so I don't want to skip this because it's super, super important. Okay, question number 2, same thing. d dx is 8, d dx of 8x cubed, okay, will give you 24x squared. Now, kalau kamu buat ini bahkan, it's logical, no, you will get this answer, right? Y equals to 8x cubed. If I dy dx this, I will get 8 times 3, 24. 24x to the power of 2, which is the same now. And so, if I integrate 24x to the power of 2 kepada dx, what I will get back is, I will get 8x cubed. Okay, so this relationship, seolah-olah, okay, it is as if ini d dx ini kamu pindah pergi sebelah. Okay, supaya dia menjadi integration. So when d dx, you move to the other side, it becomes integration. It's not a very good way of thinking, but it can work lah. Okay, if it helps you to understand that it works. Okay, although it's not actually very technically true lah. Okay, formative exercise. Sorry, today is a very simple class now, so I'm just going to do all the exercises. Formative exercise 3.1. Okay, I want you to do number 1, number 2, and number 3 and 4. Okay, I want you to do it now. Sorry, do it now. Okay, do it now and then we'll discuss. I give you about 20 minutes to do this. Okay, 20 minutes to do this. Remember this relationship, people. Okay, remember this relationship. Okay, integration and differentiation are just the opposite of one another. Okay, do it in 20 minutes and then I'll come back and then I will ask you all to answer. Okay, formative exercise 3.1, page 84. Okay, question number 1, 2, 3, 4. I'll see you in 20 minutes. Okay, hi everyone. Kenka, any problems with the questions?
Nombor 4 nggak dapat.
Nombor 4. Okay, what about the rest? All okay.
Number 4.
Number 4, okay. Since number 4 is the problem, then number 4 we do. Okay, for the rest of the questions, can I have what you do is you take a photo, okay, and then you just show your solution into the group. Is that okay? Then we don't have to waste time discussing it, but the people can just refer to your work. So Eldon, can you take a photo of number 1? Marvin, you take a photo of number 2. Somebody want to do number 3? Sorry, saya panggil Eldon dan Marvin sebab diorang yang bersuara.
Inilah saya number 3.
Then, okay, Bafandas, you post number 3 up lah. Okay, let's discuss number 4. Okay, number 4. So you have fx equals to 3x, then 2x plus 1 squared. And then you have integration of 12x squared plus 8x plus 1 is equals to afx. Ooh, interesting. Okay. The differentiation of this, obviously you have to differentiate lah. Okay, can anybody tell me what's this differentiation?
$36x squared plus 24x plus 3.
Plus 24.
X
plus 3. Okay. So, you find that if I factorize the 3 out, because you know why? We want to somehow dapatkan ini bentuk mana 12, 8 and 1 ini. Okay, so the best way to do it is to factorize the 3 out. So you get 12x squared plus 8x plus 1. And so that means when you differentiate this one, you get the yada lah. Okay, so what happens if I want to integrate this one only? Ini saja saya mau integrate. Okay, so what I will get now is okay, so this 3 is a very big pengacau bahkan. Okay, if I move the 3 across, okay, sorry, if I move the 3 across, I will get 1 over 3. I'll get this. The 3 saya pindah pergi sebelah bahkan the 3 that I factorized. Oh dear. Okay, sorry. So this is the 3 originally. So if I move it across, I will get 1 over 3. The differentiation equals to 12x squared plus 8x plus 1. Right? So because of that, okay, if I integrate this, what will happen is my f prime x will become fx. Okay, so the integration of 12x squared plus 8x plus 1 kepada dx is actually 1 over 3 fx. Therefore, a equals to 1 over 3. Okay, which means to say that if you have a number di depan sini kan, kalau kau kasih pindah pergi sebelah, it just becomes, basically 1 per lah. Sebab ini ada 3 darab. You move it across, it becomes 1 over. Okay, I mean, it just basically divides by 3. And it is not affected by the integration at all. Or it's not even affected by the differentiation. Okay, so yeah. Yeah, this is a very common SPM question. Not really sure whether it's going to come out since you guys are new syllabus. But I would say that, yeah, this is a very common SPM question. Okay, they will give it to you in such a way that macam ada bentuknya, tetapi kamu kena factorize. Then when you factorize, you find that, oh, okay, there's this number 3 that is mengacau. So you move it across. Okay, you move it across, you get 1 over 3. Okay, so A, the value is 1 over 3. Am I teaching this the right way? Kejap let me just check. Mana tahu lah kan saya salah kah? Yeah, 1 over 3. Okay, because you're moving the 3 across.